Okay, thank you very much. Warm welcome here to this Fireside Chat event about AI engineering excellence, and a warm welcome from us at the Tandem Health team, and as well as from the North Zone team, who's kindly hosting us here in their very beautiful office. Very nice. And we'll quickly introduce ourselves. I'm Oliver. I'm a co-founder and CTO of Tandem. I'll talk a bit about what Tandem does. What we do is we help clinicians focus on care, and we do this by reducing the time they spend on administration. More concretely, what we do is we've built an ambient scribe, and what this does is it listens to the patient-doctor interaction and then transcribes it, and then based on that generates a draft of a clinical note. And that means that the doctor can spend something like 20 minutes with the patient, and instead of spending 10 minutes writing a note from scratch, they can spend 2 minutes editing the note that was generated. And we're very, very glad to be hosting this event today. Cool, I'll pass it over to Anton.
Yes, very nice to be here. So much fun people I met before. And I actually had the immense pleasure of working with these two people at different companies before. So it's fun to sit down in a fire chat with friends. I worked with Oliver at Depict AI, and there I kind of felt I had this higher calling, which is about, if you love technology, what is it that you actually want to do? Well, you want to build the machine that builds all the future machines. And that's what I'm doing now at the company I started called Lovable. We're basically letting anyone build now web applications, which is a lot of software is web applications, by chatting. And we are based here in Stockholm, mostly some people in London and growing. That's me.
Nice.
And I'm Victor Kvarfort. I lead engineering at Sana, and I'm super excited to be here and chat with you about engineering excellence and all related topics, and with you, everyone in the audience as well. At Sana, we build knowledge solutions for enterprises, and part of that is a knowledge or a learning platform, and the other part of that is a knowledge assistant that can answer all the questions within a company, but now increasingly also take actions. I think we're all very much into building with LLMs and agents. I think we'll talk a bit about that, among other things.
Let's see.
Very nice. Yeah, we'll for sure get there. Yeah, so the context of this chat is that something quite big has happened. LLMs have come into this world. I'm sure kind of everyone in this room had this moment when somewhere around GPT 3.5 we're like, holy shit, this is different. This is really a different beast to what we've had before. And I mean, it enables computers to perform tasks that were completely unthinkable just 2 years ago. And it enables you to create startups and companies that were also unthinkable just 2 years ago. And the style of engineering and the type of engineering that you can do with these models is also fundamentally different, and I think that calls for different principles of engineering. And I think everyone who has tried to build and productionize an LLM application has felt the pain of the fact that it doesn't behave like regular software. It doesn't kind of produce exactly the same output for almost the same input as a regular computer program usually would do. And so that's the context of this chat. And I mean, I think all three of us have thought a lot and implemented a lot of things in relation to this. And so I want to open it up with just a question to you, Victor. Kind of what principles do you think are important when it comes to engineering LLM applications that is potentially different from previous engineering principles?
So there's many relevant principles and examples that we'll bring up, but I think one of the most important ones today in sort of this LLM era is to not build for the limitations of today's models. So do expect the models to get better. And I think Sam Altman was early to say this, and because every time they released a new version of the GPT API, they killed thousands of startups. And they want to have a bit more long-term thinking with the customers, and us building with LLMs should also have a bit more of a long-term thinking. And there's many sides of this principle in how it affects your engineering strategy and your tech stack, and I think it has broad implications.
What do you want to say something about how it affects your technical decisions on when what's the biggest factors that you should think about due to this?
I think one direct implication is to build in such a way that you can easily swap out components. It becomes even more important today, because and you have the bulldozer moving forward, which is the ever improving quality of LLMs, faster and cheaper and of higher quality. And if you try to sort of build of what's in front of that development, you will be run over by the bulldozer. So maybe sometimes you have to do that to be at the forefront of your domain, but then you need to be very ready to swap out that component. Yeah. And if you can identify this, you can maybe also look at the side of the bulldozer, like in what track will it not run, if you try to project into the future. And there maybe you can build some more stable and deep components where you do some deeper optimizations. And of course, then the balance, what's the future track of the bulldozer? Maybe there are new additional bulldozers coming that we can't foresee or so.
Right. So like really making sure that you're not putting a lot of effort into your machine being intelligent, but rather the software around it that makes the right data flow into the machine rather than making the most intelligent decisions.
Right. Sitting on the right data has always been important and continues to be, I'd say.
And you said swapping out components, which is often very hard when you have a technical architecture in production, and these components, they're two different components, depend on each other quite easy. Yeah. When you start getting many, it's very hard to swap things out. And if you have to reinvent things, you have all of software lined up, and the bulldozer is maybe going to crash all of it, and just in the end you have this bulldozer that creates all the software just instantly by asking it.
Maybe.
And then you really want to be able to have as few components as possible.
Right, because then you have to swap out everything.
Yep.
I'm curious, what do you do to make sure that the components are actually easily swappable? Like, how can you be sure when you're swapping that model to the new, faster or smarter model that is actually performing better?
Right, and I think it's not just before answering the specific swapping a model, it's we say components here, and then maybe some of your minds go to build isolated nice microservices. I think it's rather the opposite here. When you swap things out, you want to be able to work end to end quickly. And in my experience, I see more and more people working more full stack. Working more end to end, and because when you swap out a component, it's more swap out the conceptual piece of the system, and to do that you need to work end to end, and you want to have the components are not these beautifully isolated microservices, but rather I think you need a setup to be rather fluid, because what you're swapping out to might be of a very different shape. Right. So to say.
So you're saying the testing here is an actual engineer who's checking that it works end to end, and not some sort of automated testing or.
No, it's the more of the code base that you can have in your head, the easier it is to do these end-to-end changes.
Can I just add to this idea that the component should be you're saying you should not have microservices, and I just think before it took quite a long time to write the code, it took quite a long time to deploy things and change things in production, and now writing the code is at least twice as fast for me. I think it can be often 10 times faster because of the AI, right? And then the thing that is actually the bottleneck is changing the architectural components.
Right.
And then if you have one monolith with all the code in one place and you can just change all that code, then it's that bottleneck is much less of a problem.
Yeah, that's my intuition. But of course, sometimes I feel like now I have to say the other side of the story. It's sometimes it makes a lot of sense to isolate a component into a service because it maybe has very different scaling characteristics or something.
So the answer is that it depends. I heard this before.
Nice. But yeah, maybe let's move over to you, Anton. Do you have any other principle that you think is really important?
Am I allowed to rant here?
This is what we're doing.
Well, yeah. So this was a very good prompt. What are AI engineering principles that I thought about on backing here, and I kind of want to break it down. Like, can I ask a question to you actually?
Sure.
What is an engineering principle?
I guess it's a rule you would follow as you're building a piece of software.
Rule, yeah, and that's kind of useful in general. And if I break that down, I see it into at least 3 different buckets. Like, one is what you should ship, what you should build, and that's more like the product side. And then it's like how you should work, which is also an engineering principle, or there are many under that category. And finally, it's maybe what you think about instantly, that how you should engineer, AI engineer, and the technical side. I want to go into all of this, right? But if I start with, I think the top one is, as engineers, that we gain most from, is to think more about what you should build and the product side of things. And the principle that I think is most useful is that if you've worked with product managers, initially maybe you become annoyed with them saying this again and again, but then you start understanding, think more about the problem that we're trying to solve, and less oh, but I have this cool tool that I want to use, and this is a good solution here. And if you do that, you will save so many iteration cycles that you should put on what you should do first, and spend more of the iteration cycles on that, and fewer of the iteration cycles of what you might not be necessary or build later. So this is not specific to AI, but I think it's still the top principle that I've learned so many times, that you should do more of. What should we do? And with AI specifically, I think you should really do one thing that this system should do with AI, and do that really well, because you have this curse of AI, curse of AI startups, some people say, which is that yes, you can build something really fucking cool, that when it works, it's really fucking cool, but it doesn't always work. And that's in many domains that will never be enough. It just always has to work. Yeah. And then if you focus on one small problem, on what is that problem, and solve that, that's probably the place to start.
Right. So quite similar to what Victor is saying. It's get out of the way of the bulldozer. At the kind of general intelligence is getting better and better, and maybe to see by what we're doing at Tandem, right? It's get into an industry which is highly regulated, right? Where the general intelligence is never going to get into, right? Where someone will need to make it customized software that sits around the general intelligence, and don't stay in super simple but consumer-facing things that could be replaced by a more intelligent ChatGPT.
And in that process of keeping that focus, that reminds me of this maybe principle, that is keeping your tech stack simple. It relates to the previous discussion, but there's 2 sides of it, maybe not too many languages and not too many services and all of this, not too many frameworks that you get locked into and so. But the other side of that, I think, is super important, that you should, while you're doing this, keeping production boring, you should still keep exploring. Do try out all the new frameworks. Do stay up to date, but don't necessarily pull it into production, because I think it's a lot about the way. I want to take an analogy. When as a programmer, first you learn one language and then you learn some others, and then at some point I felt that I was no longer thinking in any particular language, but they were just interfaces to the more abstract sort of logic reasoning, and you could instantiate that idea in whatever language, and it just basically is different syntax. And I think the same with code and architecture more generally. You have all these fancy frameworks popping up to help you build agents so much faster and whatever. okay, look at it, see if you can learn something, and then apply it in a boring way in your production system.
Okay, that's a good one.
Boring technology is
yeah.
good technology.
Can you phrase that? This is very powerful. Can you phrase that in the short principle? Like you experiment, but translate it to something boring.
Yes, get inspired and then be bored. We have to make it more catchy.
I mean, maybe it's I feel like LangChain is a prime example of that.
Yeah.
It's like it was a new fancy framework. It was great to try it out. It allowed you to experiment very quickly, but then as soon as you put it in production, you're like, wait, shit, I mean, it's just making a call to OpenAI. I can just make it HTTP. It's like, why am I using this framework?
Writing the code is even faster these days as well. Yeah.
But I'm curious what you want on. I mean, obviously you're working to replace engineers to some degree, or at least to enable people who are not engineers to build software. What do you think, us as engineers, what should we be building? What should we be learning right now, and what should we be moving into to not be overrun by you?
Yeah. So just a quick comment on the first part there. Like the user for us now is the technical people that are super pragmatic and have this, like Victor's type of super high level understanding of how things go together. And then because then you get so much more out of a tool that just is like a command terminal to combine different things. And I think that's the answer to the question as well. It is like figure out which are the architectures that are very powerful and that will save you a lot of headaches down the line, and then pick the best tools to compile them into actual products, software products.
Right.
So yeah, I think that's.
And what do you think those architectures are?
Yeah, that's a good question. I think it is if you're building like a startup, it's often about simple web application that does most things kind of on the client, and then has some like a standard, very standardized ways to read and write to a database, and then you like start adding purchased, not built tools on top of that to solve all your other problems, where the AI is an example of like you don't do the AI yourself, you just call an API, and then you assume that the API is going to be even better in the future. But the real answer is very long. I think what the best architecture is. Right. Maybe you have some opinions here. You could get into that in the Q&A.
Yeah.
Nice.
And being a product engineer is also like I think one of the biggest level ups, and talk much more to the users or like understand the problem much more than most people do.
Nice. Yeah, go for it, Henrik.
So you guys have been talking a lot about like where you should not spend time. Also like use boring technology, don't build anything deep. But where should you go?
No, you should build deep on the side tracks of where the bulldozer will go.
Right. What's what's an example of that?
Good question, really good. Let's get more concrete and useful.
Talk to the user.
Talk to the user. Yeah. Basically, identify your domain, your niche, and the LLM vendors will just make better LLMs, right? And make some nicer tooling around it. But when we build products to solve real-world problems, we typically, the earlier in the company journey, you have a more and more niched problem that you're solving. And no bulldozer or big problem will sort of run in that area most likely, and that's where I would say you should spend that's where you should innovate. That's where so you should be going deep. Don't stay shallow in some areas and be like, I can replace the stuff. Like use the LangChain is great in one area at least, the adapters for different LLM providers. Right. Make it easy to swap that out, for example.
But I think you also had the answer before in that you should do a lot of experimentation, and there is kind of a reason why you should now these days do more experimentation, which is that previously things were quite static and like
Everything
the best
moves
ideas
faster.
slowly diffused to you from your friends, but now like there's so many great ways of doing things that we don't know because they just came up a few months ago. Like, and then you have to do more of that,
like
experimentation and so on.
caching of the input prompt or structured output in the OpenAI API. Very useful for anyone doing like structured data parsing. Now a lot of my code base is our code base is in TypeScript, so you have this ZOD runtime type checker object, and you can natively just pass that ZOD schema to the OpenAI client, and it will guarantee that you get an object of conforming to that shape, doing this guidance token probability correction under the hood. Super useful. Quite new thing in the API. So like, I think it's useful for us to not just stay abstract and fluffy, but maybe it's fun to go into some concrete, like, this was useful.
Yeah, super curious to hear more. What are some other super concrete things that you've found useful in your LLM building journey?
How concrete should we be? I'll say something that comes to mind. A lot of stuff that was tool calling or like the function calling API is now just JSON objects, and you get that flexibility. And now with structured output, I'm really happy.
I want to ask you something.
Yes.
Like, so I broke this down into what to build, how to build, and then like this more technical things.
Yeah.
What do you think are some interesting principles or way of thinking around how you should work together, and maybe related to AI or not?
Yeah. Well, I think the first one is something you guys have already mentioned, and that is that AI has really enabled you to be a lot more full stack than before, right? And it allows a lot more to be fit into one single person's head, and so you don't need to hire an infrastructure engineer for a lot longer than you used to have to. Right now, someone who is a generalist can build the infrastructure quite well, and they can actually do that infrastructure for like until you were, I don't know, 10 people in the engineering team or something, or 20 people. Like, that's not the problem. Whereas before, you definitely needed someone who knew how to write all those pesky YAML files. Like, and so I think that's.
We don't need that anymore. But instead, we take down production when the AI
exactly. Instead, you like very frenetically talk to ChatGPT as production is down and try to figure out what's wrong. No, but so I think that's one really clear thing, right? As soon as, and you mentioned as well, right? As soon as one person can see the entire stack and try things out, that allows for way greater experimentation, and it allows you to keep your team a lot leaner. So I think that's a very clear learning from these past couple of years.
Yeah, interesting.
I think it's interesting that you go to sort of the topic of how to work well together in a team. And as you're saying, that maintaining the ownership as you keep growing and the code base keeps growing, and you start having even pieces of the code base that feel like legacy, no one touched it for a while, maintaining the sense of ownership and the feeling that, like, oh, it's weird over here, but it's not my problem. That's very dangerous.
Yeah.
What do you do to combat that?
That is a good question. Do you have it's more of a, what do you say, like team spirit question, maybe? Do you have some tricks for that?
How do you mean?
Like, how do you make people excited about touching ugly, messy code that if I touch it, it becomes my problem?
Yeah, how do you instill the spirit of ownership? I think it has to be on the company level, from the beginning, top down, across the entire organization. And really, I think it's a lot about the insight that if I don't act on this, who should act on it? Like, and you should be also empowered. Yeah, exactly. What would happen if I feel this is wrong, but I don't act on it? The snowball effect of that is detrimental.
Yes. And I think the only way to do that is that all engineers have to be close to the product and feel the pain of the users of the product when something is not working.
And also this, like, everyone becoming more full stack is one way to facilitate it, because otherwise, the problem is on the back end. I am not the back end engineer.
Right.
If you remove those boundaries and work more like fluid or sort of horizontally across the stack.
Right. Well, the one thing I can see in my own code writing as well is as I've become more full stack myself, using LLMs to be better at the full stack, I'm also producing a lot more code, but also code that I maybe care less about because a large chunk of it has been generated by the LLM. How do you make sure that people kind of keep caring about the code that they're writing, even though most of it is generated by LLM? Or do they need to care?
That's my question. Do you actually need to care as much about all this code that you can just delete and rewrite? I think you need to care more about some of these like architectural decisions so that it's easy to change things, but less about like this how this front-end component works internally, as long as it's like well split out from the other things.
Right. Yes, Ulmer, we have a question here. Maybe Alessandro, you can give the mic to Ulmer just to make sure that it works.
Yeah, for sure. So related to this, like, how do you guys think the dynamics of tech debt has evolved, like pre versus post LLMs and code writing?
I can give one quick anecdote. So I've been in a lot of engineering interviews, and I try to keep the interviews as close as possible to the real world scenario of actually working together. And so it's kind of writing code together is one of the tasks, and generally allow the candidate to sort of use whatever tools they're using normally. And one candidate was pressing tab a lot with autocomplete from Copilot, and produced a lot of code in a short amount of time. Very much failed the interview because the code didn't do what it should do, and this candidate got lost in his own code.
Right.
So you can produce very much like a lot of tech debt very quickly if you generate the wrong code. That's a challenge, and to counteract that kind of thing happening, I mean, in one way I very much agree with you, Anton. Projecting into the future, I think we will care less about details, just as no one here probably cares so much about what machine code it compiles down to, while people long ago cared a lot. Now we're climbing up in abstraction. But one way to keep it, to keep the quality, I think, is to be guided by the mathematical kind of idea of elegance or beauty.
Interesting.
To
answer the question quickly, I want to reiterate what we spoke a bit before with what you just said. Like, we should be guided by elegance and beauty more on the like on the how many components and that have a more of a hard to change communication pattern like HTTP requests, and less on elegant and beauty in like having many duplicates.
Would you allow spaghetti code?
I don't think so. But it depends on what spaghetti code means. Like if you have duplicate code patterns in a lot of places, I wouldn't care as much these days, but I still care.
I see the point. Yeah,
and I think the cost of debt is a lot lower because the cost of like refactoring is way lower. So if you're unsure, I think it's even better today to actually leave it than it was before, because in the future you might have more information to know what the refactor you should make. So I actually think tech debt is less important now than it used to be. Like we can have more of it and be fine with that.
We'll see what you say in a few years when you sit there with your legacy code.
That's very true. We'll see. Nice. All right.
I've got a very specific question. It's about prompts and prompt management. So, you obviously write a lot of prompts, I guess, if you're using LLMs. Do you see that as a part of a function, like it's its own kind of isolated sort of behavior that belongs to that function? Or do you see it like something separate that should be managed separately? Because there's a lot of that happening now as well.
Yeah, good question. I'm so curious. I want to hear what other people say here.
Yeah. So we're treating it as something quite separate right now. For us, medical knowledge and medical understanding is very important. So we have medical experts on the team who are helping us write the prompts to ensure we have really good medical correctness in what we do. And so that means, since they're not engineers, it's quite important for us to have that separate from the system. But that of course creates problems as well, because it is part of a function, it is part of some flow of data, and you do need to at least least sometimes understand the code that sits around that prompt in order to fully or to get the right performance. And so it's something that we're discussing a lot internally. Should we treat prompts like this as a separate thing, or should they more be like data that's part of the system? So I don't have a clear answer, but that's how we're doing it right now. Curious to hear what you guys think.
I think the answer is both. It depends, because when it's like a super simple thing you want to do that is almost always succeeds, it's a function. And then sometimes otherwise you want to do like your A/B tests among these prompts and like make them user editable almost. And then there's something else.
Yeah, in the simpler case where it's just a prompt, I think I almost think of it as, you know how with style components you sort of just inline your CSS, it's a different language there. You can do the same with your SQL queries, you sort of just inline them, and you maybe have some template literals. Same here, you happen to inline another language and it happens to be English. But it's part of like all code is some kind of description, algorithm, specification. It can be Python or TypeScript or English in this case. But I agree with you. So when the other case is when the prompt is to a model that you're fine-tuning, maybe, and you have like this data set and you're cleaning it and collecting it from production in some way and then retraining and or retuning. In this case, we think about it quite separately.
I should say we're now also opening it up to questions from anyone from the audience. So feel free to.
They cheated.
I happen to have the mic, so this is great.
Yes, convenient.
No, I'm thinking, kind of going back to what we said earlier. Do you think that the role of the specialist changes? Are people becoming more generalists, and are we getting rid of the specialists? Or is it more that the abstraction level changes and the role of the specialist is still just as important?
Yeah, so I think it kind of bifurcates, or it splits up the specialist role. I think there's less room for someone who is like 95th percentile good at something. I think that is going away a lot because you can use LLMs to understand something to like the 95th percentile. But I think the 99.99th percentile person, those are still going to be there, and they're going to be incredibly important because there are going to be lots of times where the model is not able to figure it out, and then you're going to have to escape hatch into a human, and they're going to be really well paid and really sought after, the ones who are like world level experts at something.
They sound like consultants to me.
Yeah, I mean,
do you happen to be a consultant?
I have this startup idea that you just pool all of those 99.9% people, because that's also going to be the only training data for the LLMs that matters, because everything else you can just generate from an LLM, right? So much to do.
That's good. Shaman can jump on that. Yeah, what do you guys think?
Yeah, what you said. The LLM is a specialist already, much better than me at.
But it's also a generalist.
True, yes, but it doesn't have the.
But I see many of my peers and fellow engineers. I see it's, as you described, going broader in the stack because it's easier now. You don't have to spend so much time to gain that experience. You get there faster. And at Sana for a long time in our hiring sort of thinking, we've been speaking a lot about T-shaped individuals, right? These generalists, and the T-shape is that horizontally, like they're broad, full stack or whatever, and then they have their vertical where they have their niche. And the AI full stack engineer that I see becoming more of a thing, very useful to work with in production system. Maybe they have their niche being maybe a stronger background in mathematics, for example, or something like this, or just machine learning, and having the deeper intuition and hands-on experience from the past of actually working with models, tuning them, understanding trade-offs and these types of things, having the intuition of how to best gather data, when to do fine-tunings and so on, but then being broad because they quickly just prompted GPT to learn how to write some React code, and then they can be working end-to-end and then replacing conceptual components in the code base. And now we're speaking more about pie-shaped individuals because it's easier to get an expert in two areas. And it's not just T-shaped.
It's like very bad and very good, but it depends on how you...
Depends on the font.
I have a kind of a question topic that we haven't covered, and I think it's so intriguing. It's like in engineering in general, you often, when you're serious, you care a lot about observability, being able to understand and hunt down problems in your system, and also like testing. And what's the best way to do that when you have LLMs involved?
Yeah.
I'm sure you both are doing things that I don't know that could be interesting.
Yeah, I think for observability, at least on our end, I don't think things have changed. It's still just as important to do really good observability, and it's just easier now. Like the cost of implementing observability is lower because it's very easy to have ChatGPT generate how to do it for you.
Yeah.
And so I think that hasn't really changed. It's just easier. For testing, that's something we are struggling with a lot, how to test your LLMs, because there's so many, it's so fuzzy, the inputs and the outputs, and how to make sure that it works well. And I think we have some kind of basic unit testing in place, but it is really scary when you go up for this moment where you're going to switch the model from GPT-4 to GPT-4o or something like this. How do you ensure that? And for us, really, it's when we have had the benefit of being able to observe things in production and seeing, testing this for some cohort of users and seeing what is the effect, and then was that positive or not.
Have either of you broken like production, like in a complex LLM application?
Of course.
Yeah.
Yeah.
And because that's a bit harder to know, like does the production work or not now with the LLMs involved?
Yes.
And
it might be a lot fuzzier, right? It might be that it doesn't work in 20% of the cases because the model starts saying I can't complete that task or whatever.
That's a great point with this fuzziness of it, and either maybe you can come up with some way to in a fuzzy way score the output, and then you can sort of see statistical trends in how you change things. But I can take a concrete example from our side. So in the knowledge assistant, part of it is a RAG system, retrieval augmented generation, right? So one part of the system is basically a search engine gathering the most relevant context that is then put into the prompt. And so to test the knowledge assistant end to end, you have the fuzziness of the LLM generating the final answer. That is like human language response. So instead, as one key thing we're doing in the testing is testing the retrieval. Given an input question, and this, we just basically have a long list of what we need to test from different domains. We know what should be the top ranking documents. What my point here is that this is a concrete example of a more general principle, maybe. Try to find things, if the end-to-end is fuzzy, identify a sub-process of that is not fuzzy and test that. And still you could make it, in this case, it could be a bit fuzzy. You say, I know that this particular, given the question, this particular chunk or context should rank at least top 5. And then you can still have some leeway as we're changing the embedding model, vector embedding model for vector search.
Yeah.
Right. And what about the G part of things? Is there any other breakdown you can make there?
You can have another LLM assess the output.
Yes, I can just comment.
Exactly. I mean, that's what I was gonna ask about, because often, in many cases, it's very much easier to verify an answer than coming up with the answer.
Yes.
For example, you are generating software, Anton. I mean, it's much easier to verify that the Sudoku is correctly solved than actually producing a program that solves a Sudoku. That's more difficult. So I think even simpler models can be used to verify answers in many different domains. Software is also very easy sometimes, because you can verify an answer like logically, but
exactly.
Also models can verify answers, because it's often easier to verify than coming up with it.
100%. And in the concrete example I described with this knowledge assistant, the RAG system, the prompt to the LLM that checks the answer can be as simple as is the answer based on the context? Because it will see the chunks and then the answer, and then what's the answer here is easier than doing the logic to derive the answer. And then you can prompt in different ways. There's different scores of
One strategy I actually used before, which is maybe useful to you, is that you transpose the answer in terms of a more kind of like a binary thing, so something more discrete. So instead of like a paragraph or an answer, you actually have it as it's like a yes or no.
Yeah.
So if you're retrieving some piece of information, you transpose it as in like, is this correct or is this not correct? Because then you can have a very discrete statement, like it's a Boolean basically,
Right.
you know, or picking categories, like which one of these three is correct. So that's like one technique that may help.
Interesting.
Can I think I can also add to that something that's not LLM based is just having some kind of evaluation data set that is human based, and that can be really hard to create. But the benefit of that is also that you are formalizing what you are actually evaluating. So it can be good for oneself to create an evaluation data set, even more so than just actually using it.
Yeah. And in the case of question answering,
Yes.
you can very easily synthetically build up a validation set of have an LLM read some documents and come up with question and answer. Because it will be there in the document. It's easy. That's a rather easy task.
In my experience, it doesn't work.
Aha, interesting.
It could work, I guess, for some tasks.
Yeah.
But I
just
like
wanna-
human evaluation.
I just want to echo what you said, Peter. The things that we added, like that, just super nice, is that some services always hitting our production with like a happy path end to end with the LLM calls and everything, and then checks that the output is like reasonable, and also just on every generation of software, asking another LLM, does this work? And you can look at those more ambiguous metrics. And I'm doing that offline as well, but having it in production is very
This kind of
good.
integration testing or end-to-end testing, I think, is just like you're saying, becoming more and more the standard in many ways. And some companies are building LLM agents to do this even more high level. You just like check that the login works, and then no matter what you change, like you can change a lot without the test breaking. But I don't think, they're getting more and more stable.
Interesting. Yeah.
Nice. Does anybody else have a question?
So you've been in the industry for a long time, and this chat is about AI engineering. How do you think about the skills of a really good AI engineer in 2024? Like what? Previously, it's been a lot about prototyping, training your own models, etc. How do you see that changing now with more and more foundation models? And how should let's say a new grad think about career progression and so on?
Try all the tools fast.
Staying
they
up to
come
date
out,
with both the concrete like developments in the APIs and frameworks, but also on the research side, to stay a bit ahead, to be able to see further where will the bulldozers go.
And learn how to build end-to-end, learn how to build products.
And make things actually as simple as you can. Like you shouldn't add LLM calls fucking everywhere when you can actually use like a heuristic, which is just code, because that's usually makes you move much faster.
But I'm curious to know from you guys, do you think there is room for ML engineering still? Like, are there still things that should be done by a traditional clustering algorithm, or that you actually train something? Like, is there room for that?
Yeah, so it feels to me, I haven't thought so much about it, but it feels to me like there is, like the field of data processing is very intact, and like both for like analytics purposes and also like data processing for regenerating the next generation on Spotify's Discovery Weekly, and there you have you probably use those algorithms in some cases, like you have to know when to use which algorithm, so yes, but you probably I think there is. I'm not sure.
Yeah, I think it moves. How do you say, like up market, or to more mature, established companies and products. Because for a startup, of course, you want to move fast and be very, very flexible and so on. So LLMs are just fantastic, a very versatile tool. You can do a lot very quickly. The relative cost of like doing a lot of R&D on something is like very high cost and uncertainty. But when you have a sort of established product, I don't know, recommendation algorithm in Spotify or Blocket or like anything like this, I think there still is a lot of value to be captured by, for one thing, just like replace the big clunky model that you prompted or whatever with something much more lightweight that maybe you tuned yourself, because you can save a lot of cost. Like it would be cheaper to run it and maybe even faster. So I think from what I see, the individuals with that kind of background, they are working more in these kinds of contexts, or very much enjoying prompting.
So it's a question of where you get the benefits of, well, where you have a very large scale, you can get the benefits of efficiency, whereas when you're small, it's about moving fast, and then you don't have time to do it.
I just one thing that comes to me with this ML engineer is that I think ML engineers have done a lot of harm by being like having their hammer and wanting to apply it way too much when you should have done software engineering and like solve some other problem. This is the wrong problem to solve, and I think that maybe applies even more now, that you should not use your own model, you should use an open AI call, whatever. So that's the part of it. But I maybe we're out of time here. I'm curious to hear, like, this audience is much smarter than me in some areas. If someone would like to roast and be like, no guys, I would like to add this, or say that we were wrong, is even more fun. It's a challenge to you all.
I would say you're wrong, but there's like like one theory that I have is it helps, is that because, as you said, try to be fast and use as many tools as you can and put them together into a product and keep it simple, right? You're moving up in your level of abstraction, so a lot of people aren't writing C code these days, right? So it's usually Python or TypeScript. And this is where I'm circling back to you now, actually, because we have an Apple guy here, right? And the point is that the more people do this, the more you will succeed, because you'll be able to generate this code very well, and the whole system eventually, right? But what is going to fall back is the foundations, which is writing like optimal, like C code, for example, and the entire AI industry, the entire ecosystem is built on top of this code that's only known by a very few people to execute very well. So like when, I've been doing this for 18 years, right? Did like embedded telecom systems for 10 years. And when people come to me like, what should I do, out of uni? I'm like, well, just learn how to do C code like really well,
So you become one of those experts that, the real
automated way.
No, at the 99.9%,
Anyone else?
Yeah, I really liked what you said about search. I don't think you talked about search enough, because in a lot of contexts, quotation or citations are really, really important. And, you can make sure the model basically never answers something wrong if you don't give it too much context and you give it relevant context. So I don't think everything can benefit from this, but just putting a lot of effort into building a big search team, or just spending a lot of time on search, has such a huge value, and it's intact to models getting better, because they'll be better at using the context, but you're still giving them great context, right? And I think it's not something that is talked about enough, really.
I'm glad you say it like this. This is how we're staffing up the team to a large extent. That's one area where we're going very deep. We have, and it's like doing this on large scale is also very difficult. Like the ingestion system, dealing with suddenly someone, an enterprise partner connects hundreds of thousands of PDFs of product manuals and whatnot, and videos and everything, and this needs to be converted down to text and then chunked and then create vector embeddings for it. Our vector database, like silly amounts of RAM is needed, so we have to convert it to like use quantized embeddings and stuff, and run a re-ranker. We run a re-ranker, a cross encoder, and like there's many things to be done here. And on the one hand, OpenAI is doing this nicely with up to 100,000 documents. You can just like put it into the API and then it does RAG for you. But you have no control. You can tune it. You don't know like, oh, I want citations to behave in this way or whatever. So I think we are approaching it like you're saying. This is an area where there's a lot of value to sort of go deep. And when new LLMs come out or new vector embedding models, we just directly adopt them and our system gets better. So we build up this structure. And increasingly, like you're building a lot with agents, and one place where we have more and more agentic stuff is actually in the search process. Like we call it the query planner. So the user writes something. It can be a question, and the response should be an answer, or the input can be the user asking the system to take an action, like update Salesforce based on this meeting, if you're a salesperson, for example. And then there's a tuned LLM, so we're self-hosting a Llama model doing this routing, but it's also now increasingly running in many steps to do like searches in different, not just a vector search, but we're building and generating dynamically like a knowledge graph of our customers' unstructured data. And it's dynamic, so it doesn't know a priori like what's in there. So it's like generating a query, looking in there. This is what I found. Okay, I should do this search now. So this is super interesting.
Exactly. Can I ask a follow-up question, maybe to you first? So don't leave the mic. Yeah. Like when you say search, do you think it's important with vector search or also classical search? Like understanding those algorithms better these days.
Yeah. Both. Hybrid search. Why not? You can generate keywords. You can even generate Elasticsearch queries, and then it becomes a question of when you process the documents, you can extract metadata, and which you later query. And you only do that once, but you always have the metadata, so if someone asks about the same document, it's there.
Right.
So I think there's a lot of room for classic search or keyword search still.
What do you think about, so if the vector embedding models are great, but they don't understand sort of domain-specific terms or internal acronyms, but you can tune the models. So if you have that corpus, you can tune it, and then it will be able to pick up on that. Do you have any intuition about how far you can take that approach versus actually going with more classical, like BM25 or something like this?
What we've done at least is to basically use LLMs to generate queries. You can generate hypothetical embeddings like using HIDE. That has been very successful. But not tuning our own models, really. Haven't explored that, so I can't say.
I can recommend to explore a bit. But also, as a general rule of thumb, depending on where you are as a company, avoid tuning. Don't be the ML engineer. If you want to be in a situation where you can move fast and swap things out.
In a few months, they will be something new. And then it wasn't so awkward.
Like one concrete example here is, you go back some time and the vector embedding models were kind of one-sided, and you had to do this kind of thing of transforming the query to look like an answer to increase the probability of finding the answer. But now they are tuned kind of asymmetrically, or like you can prompt them. You say this is the query or this is the document, and they are trained on that. So that problem disappeared.
Yeah.
Nice. All right, we'd have for one final question from the back there. Or sorry, okay, we can do two final questions. That's fine.
Thank you. Okay, so I think you've kind of been onto this fact that like right now things are moving very fast, and we're not in sort of like a stable system over time. It's not going to be like this a year from now. And so I wanted to ask your questions on like, how do you guys think that LLMs change moats inherently? So like it seems like Oliver and Lucas, you've made a bet on like regulatory moats are still going to be there. So even though there's like super intelligent AI potentially, people are still gonna like the regulatory moats are still gonna sort of save you in that sense. But like, how do you guys see that moving forward?
Yeah, well, I guess the main moat that's being demolished is the moat of just amount of software, because the cost of building that software is just going to go down. So, like if a company like Facebook, their moat is unmoved because their moat is based on a network, exactly. And like you can make Facebook as a school project. It's not very hard. Whereas a company like Slack, they have some network effects in there, but mainly it's just some software. And now any large company can make a Slack that's completely tailored to them and to their needs very soon, for a very low price. And so I think their moat is very much going away. Although I think with Slack Connect, it's different. And so yeah, I think that's just the main thing. Is your moat cannot be that we have a lot of software that's hard to implement. No, that's going away.
I can comment quickly on that. I think you can, being the platform in some sense, like the go-to where that has all of these other integrations, has everything packaged in, and you pay one bill, like it covers all of these other things, is a very strong place to be in. You can try to become that player.
Yeah.
Yeah, Kevin here. Last 12 months, I have been lucky enough to work for a few large enterprise and mostly RAG in banking, healthcare, and also retailer, building of different systems. I think I very much agree on like you can fine tuning the domestic data to make the embedding model even outperform like OpenAI's model. But I mean, it's very great, like a marketing message saying you have like a methodology, you can fine tuning the domain adaptation, right? But on the other hand, I also realize once do that, often the gain, let's say you get a 6% gain with fine tuning, the gain is diminished when you apply re-ranking. Because re-ranking is so powerful with cross-encoder. Do you also fine tune re-ranking models? Different domain?
We haven't had, that is not where our bottleneck has been.
Okay. No, that's my question.
All right, well, thank you very much. So we're going to wrap it up here pretty much shortly. There's going to be some pizza, and right now there's plenty of beer and wine and non-alcoholic drinks for you to have and keep the conversation going. Thanks a lot to everyone for coming, and I hope this was fun and useful.